So how do we interpret these regression coefficients? We found out that all of these are statistically significant. In other words, it's very unlikely that these are statistical noise or flukes. It's very likely that there really is a real relationship between these variables and the price of cars. Now, the age in years, as each age increases by a year, then the value of the car drops by this much. Having an air conditioner in the car is associated with an increase of price of the car of this much. Having an automatic air conditioner also is associated with having a very large increase in price. It's likely that this is not that having an automatic air conditioner in your car that will regulate the temperature is worth that much more in the car. It's more likely that there is other things in addition with that automatic air conditioner that makes that car more of a luxury vehicle that we don't have visibility on in the data. There might be leather seats, for example. There might be bucket seats. There might be an especially nice stereo system or something like that that we don't have visibility otherwise in this data. For every month of guarantee left, it's $50. And also for each horsepower that the car has, it's about $17. For every kilometer it goes, it is losing value by about 1.5 cents a kilometer. If the manufacturer's guarantee is still in effect, then it's associated with a higher price. Power windows are associated with a higher price. Tow bar actually reduces the value of the car. And then there also is a positive relationship between the weight of the car in kilograms and the value of the car. So for every kilogram the car has, it is worth about $12 more in terms of price. And it's probably, as I mentioned earlier, it's probably something to do with aftermarket things that are added to this car or other features that are added to the car that make it more valuable. One way to think about this would be to say that a car that is just bare bones would be lighter than a car that is especially nice or that has had additional features added to it. So we would essentially multiply the values of the variables, the x values, if you want to think about it that way, times these coefficients, and then sum all of those up, and then that would be the price of a car. You can also apply this model by taking data that currently exists that has data column names that are the same as what the data was derived on. So for example, if I open up another copy of this data, then I can drag that on the model and generate predictions, and it will actually let me see what my predictions are. So you'll see it says predicted here. If we look at this in the data table viewer, then we have the actual price, we have what the model predicted the price was, and then we have the residual or the error. And this is how much error there was or residual there was, which was the difference between the actual price and the predicted price by the model. You'll notice that sometimes our model predict prices that are higher than they actually are, and sometimes the model predicted prices that were lower than they actually are.